Good evening to everyone present here. Thank you, students, for joining, and I welcome you all to this hands-on session from scratch on breast cancer prediction using SVM. So, before beginning our session, I would like to give a short detail about our organization. So, we are from OpenWeaver company. OpenWeaver is a global tech company with over 1 million users. We help students and software developers build applications faster with open source and cloud. Also, our mission is to champion reuse of software through open source and cloud. So, as part of this mission, we conduct boot camps and sponsor hackathons, which are part of a Rapid Hack initiative to help students develop industry ready digital skills. So, today our mentor is Pooja Agarwal. She is a senior developer advocate at OpenWeaver. She completed her master's degree in IIIT Delhi and also has 5 years of diverse experience in AI, ML, cloud, and IoT. So, welcome you, Pooja. Let's begin the session. Over.
Hi everyone. Uh, so we'll start a session for today, and I'll just share my screen. So I guess before I share my screen, I'll also quickly share with you the link for our starter kit that will be helpful for all of you to begin the session by installing the available code as a kit. So let me share it. I've shared the link in the chat. Once you click the link in the provided in the chat, hello everyone. Greetings to you all as well. So once you click on the link that is provided in the chat, you will be able to open this kit, right? You will be able to come up to this page and you'll be able to open this page and click on this one click install available. So what we usually do is, as whoever has followed most of our sessions up till now, and all those who are even new for our sessions, they understand that we have curated some kits for you so that you are more comfortable quickly installing some kits and starting and trying to understand how you can utilize different codes available as open source repositories on GitHub, etc. So we picked up a repository also and tried to curate a research based topic on breast cancer prediction for you today. So before I start discussing in detail, I first want you to quickly go through this installation. So you can just install it anywhere on your desktop, and it's in the form of a zip file. So you can quickly go and navigate to the folder wherever it is present and extract all of it. So I'll just put up a name here so that it can simply create a folder. Okay, and you can see I have just unzipped the file on my desktop, and the moment I unzip it, I get a batch file. You just have to double click this batch file. You will see that your windows will try to protect you because it's a batch file. It will try to download some dependencies for you so that you are able to even after not having Python, not having Jupyter notebook, not having the right libraries, you would be comfortably able to start working directly on the notebook or start understanding the code with us as I am going to take you over through this session. So that is why your Windows tries to give you this message. You don't have to worry about it. You simply have to say more info and go into run anyway. You will see that your CandyKit installation will start. It will start the download. There will be very small amount of libraries that are required for this setup of your kit. So that sort of installation should start. You can minimize this screen once you get your download up and running. I mean your installation up and running. Sorry, apologies. So we already downloaded it, and you will see in couple of minutes we'll have your automatic Jupyter notebook being opened. Up till now, we just have the requirements file being shown. So let us go to our presentation for now. Uh, I hope most of you have followed. In case you have joined us a little later, I just want to quickly give you a brief that we have just done the installation of the kit that will be used to do the prediction for breast cancer today. Okay. So in case you have doubts, you can ask me. Post I discuss all the important topics, which will be helpful for you to understand how you can, or from a research perspective, be able to develop a model in AI for such a prediction. And many more predictions can be done based on this one example that we are giving you here today. So under our Rapid Acts initiative, we do such boot camps regularly within the week, and we try to understand what your requirements are. Where our next session would be on Python basics. So I look forward to all those who still are a little in the beginner mode, where they think that they somehow are not still able to get a hack of it. So we have tried to build up the most basic session for you this Friday. So however, for today's session we will discuss how you can, first of all, the problem discussion, that why do I chose to tackle such a problem, or why do we want to predict something this sensitive, right? From a perspective of overall different problem areas that are available to be solved. Why we'll discuss why this was chosen, and then we will talk about how machine learning helps to handle this breast cancer prediction. And then we will talk about one of the important algorithms of support called support vector machines, and how it is different, and how does it function, and how one of its linear aspects of classification helps us clearly segregate our tumor from a cancerous to a non-cancerous tumor, right? So we'll talk about that prediction, and then we will quickly move into our hands-on session on breast cancer prediction. So, quickly talking about the statistics here. If you see all throughout the world, this problem has been there for a long time, and even till today, it is being found in the women all throughout the world, with an estimate of over 2 million new cases recorded. And these stats have been taken up based on the research that was performed by WHO and the International Agency for Research on Cancer, that in only 2020 there were over 2 million new cases that were diagnosed and around the world, and 1 in 8 women in the US are diagnosed with breast cancer. And to be honest, if we talk about the South Asian region, most of the cases go unreported. However, we still have some stats with us. However, we still have some stats with us, where you see the South Central Asia, where primarily China is in the central region. And if we talk about, you know, not primarily Southeastern Asia, where again you have uh, all the eastern countries too, which are there in the Bay of Bengal, including our own peninsular continent. So all these stats somewhere show that there is a decent amount of women and also men who get affected with breast cancer. There is a myth, like people think that it is only the women who get affected. But yes, if you see the stats here, every 46 seconds, somewhere in the world, someone dies from breast cancer. That's more than 1,800 women and men every day. So yeah, it's also common in men, but mostly it's seen in women, and hence thought of that only women suffer from this issue. So in 2020, which was the latest stats that were available, so I could pick up from there only. There were more than 7 million people in the world living with breast cancer. So we want to try to help in the diagnosis. I won't say that we can remove, like we can completely avoid it. We can just help with the diagnosis. Early diagnosis is always better to help someone, prevent serious stage 4 cancer from no longer. Now even you can see in the news that cancer is no longer a big death causing disease. That thing is very recently seen, and again AI has played a role in making cancer patients more cured and more healthy from its complications. So yes, coming to this part, let us talk about machine learning now. Let us understand how this technology aspect of artificial intelligence, where we say we want to train the machines to behave like humans, to give them the same cognition that we as humans have, can benefit us, and I would say help us in various issues of our life. So machine learning can be summarized or can be partly divided into supervised and unsupervised. It can also have more components where you can talk about machine learning. However, we will try to concentrate only to the aspect that we want to discuss today, so that specifically falls into classification and regression. So first I will talk about what supervised mode of learning is, how you can supervise your machine to learn better and perform better. So basically, in the supervised mode of learning, exactly what happens is, you do provide your machine with the target output. Or when I say a target output, we basically say that you know that your machine basically would be provided obviously with the input, right, that can be structured or unstructured, but you will also provide with the expected output, so that the expected output or the result is what you call your target output. And that expected or targeted output would basically help you to easily train your model. When you know what you want to achieve from a particular input that you're providing to your machine, then you are easily able to reach that goal. So somehow it's an easier way of training, and that was first introduced. And then after that, we came up with the unsupervised mode of learning, where you had you know set of data points. You had the data, it was all unstructured. However, irrespective of all that, uh, the machines became the models. The unsupervised models were intelligent enough to do certain computations for you, where they could segregate different data points, and after separating them, they could also place data points with similar characteristics into one group. So that was something that basically benefit us a lot, and that's how we are able to come up to the scenario where we are today, where you see that based on your Twitter post, based on your Facebook chats, and whatever communication that is going on today, which is being done today, uh, every information is being shared with the different corporate organizations after your permission, where you say I agree on downloading a free of cost application. So you have to be very aware of what application you are using, even if it's free of cost, and how is it taking up information from you, because data is the new money, right? So Netflix knows that what is the next genre, I mean, what is the genre that it should offer you, right? And also Netflix, I would say Amazon knows what is the next product that you would like to buy. So all that, those sorts of suggestions, recommendations, your systems that are built on intelligence by learning from your habits, have been built up under the machine learning techniques. And we have to discuss classification today under the supervised category. So classification and regression, let us try to understand these two specific learning techniques that we would want to employ for helping us with prediction today. So classification, as the name suggests, it basically uh, gives you a problems solution in a yes or no form. Or basically I can give you a quick example of where you would say either you passed or you didn't pass, right? Or either the tumor is cancerous or the tumor is non-cancerous, right? Where we have two or more than two classes. However, either it is limited to usually two or say multiple classes, but it is easier for you to classify a certain set of issues or problems into those classes. Then comes your regression problem. So when classification is there, obviously regression problems are also there. So if I like to take an example of a regression problem, consider the stock market as your regression problem, where the stock prices keep changing. Consider a problem of employee salary prediction, that a certain employee at a certain designation will have a certain uh, salary. That is not a yes or no. It is something that is based on numbers. It is something that is based on varying numbers, or I would say it can range from some thousands to some other thousands, right? So that comes into a category of range of values. So such problems, when we want to deal, we will use some regression algorithms. When we want to get an answer into a yes or no form, then we would want to apply a classification problem scenario, right, to solve our issues. So now we picked up support vector machines today. So earlier we've done a session on this. The reason for that was I tried to pick up a research paper, and based on a research paper's implementation, we wanted to discuss how you can work on solving, taking a toy data set. So I quickly want to tell you, today we will work on a toy data set from sklearn's library. And just don't get overwhelmed. Just for now, have a bit of patience. When we go through the hands-on session, maybe you would be able to resonate more. Just think svm is a algorithm that I'm using. And what is an algorithm? It is basically a set of instructions that I try to use to train my software to function in a certain manner, right? I want to instruct my machine to function in a certain manner, right? Or I want to create a software that does a certain task for me. So I am using my support vector machine algorithm to do. So in even in the support vector machines, we can have both classification and regression sort of svm. And we are choosing the classification svm today. So the reason for that is the kind of problem that we have. If you quickly see, we do have a problem where we can simply classify it in the form of either the tumor. I'm talking about a breast cancer tumor. So it can be either cancerous or it can be non-cancerous, right? So quickly moving on to this graph here, and you may think that what am I trying to do here? So basically, I'm just trying to quickly make you understand that with the help of these data points that you see on the screen. Okay, sorry. Okay, we'll just use the laser pointer for now. So yes, with the help of these data points that you can see are in the circular green form here, and some blue squares that are present at the top here, what am I trying to do? So just try to resonate these green square as data points, and these blue squares as another sort of data points. What we're trying to do is, we have certain data, and now we want to divide and separate those data points as much as possible. The reason is, we want to have maximum separation. Only then we are clearly able to state when a new point comes, whether it lies in class or category 1, or whether it lies in class or category 2. So let us consider, as this is represented by another color and shape, and this is represented by another color and shape, that this is one class and this is another class, right? This is your one class and this is your, okay, somehow my ink isn't working as I'm not able to identify it well today. So I will just stick to my laser pointer back again. So what I'm trying to state is that, think that this is a category where I'm saying that the patient has cancer, and this is the all patients who do not have cancer. Let's take it like that. I said that in supervised learning we do have the target, uh, or the output column with us. So when I say that, in this first column that we are trying to, or the first, sorry, category class that we are trying to state whether the person has a cancer or not, we denote it with these blue squares, and we say that, okay, whichever point lies above this dark hard margin, maximum margin, has cancer. Who, whatever points or whatever people are lying below this line, are not having any cancer. So first things first, we want to say whether there is cancer or not, whether the tumor is cancerous or it is benign, right? First thing is that. Another thing is, how do you do it? So what sort of an algorithm? So we say support vector machines. So let us try and understand what sort of vectors, what sort of support vectors are there in this. Exactly what happens amongst your data points itself. See, these are my data points, and these are also my data points. Amongst these only, I will try to find a vector. I will try to find a point that is, if I see this entire batch of points, the point that is lying farther from the class, and also I will try to see which point lies farther in this class, and that is obviously towards the place where we have, I would say, the maximum chances that a overlapping is happening. So we want to reduce an overlap, right? We want to say that there is a maximum margin, there is a maximum distance in the two classes, and we are clearly able to distinguish or separate them into n dimensional spaces, right? So that is what we are trying to do here. So for that, you use hyperplane. So hyperplanes are, basically something that you understand from mathematics. These are these sorts of parallel lines that you draw. And how do you basically use these lines to separate? You use the points which are farther in the class, right, which lie at the boundary of the class, and through those you draw the dashed or dashed lines, and you draw dashed lines through the support vectors at both the classes, right, at the boundary of both the classes. Boundary of this class, say this was class B, and boundary of this class, which is class A. Once we have these parallel lines, we also try to find a maximum hard margin line in the between, which lies at an equal distance from this dashed class 1, I would say, hyperplane, and from this, again, another hyperplane line. So what I would want to say, how do I choose that the line should be this? If I want to ask for a maximum separation, there is also one way where I can simply use my pen and draw a line like this. Please avoid that previous line. Okay, right? So why can't I draw a line like this? That also does the separation. That also basically separates these points and these points clearly. So if anyone who has an answer to this, they can quickly put it in the chat so that others can also, be supportive and accordingly answer. However, what I'm saying is, does this line not separate these points clearly? But why would I chose a line slanting like this? Anyone who knows the answer to it, please answer. I will obviously be stating it in a minute, and I would want to understand how many of you were able to understand. And we can say that one side of the line is, say, negative hyperplane, other side of the line, whichever points lie on the right hand side are the positive ones, the ones which lie on the left hand side are the negative ones. Just similar to what this hyperplane is trying to show. So I guess we may have had some answers. If not, let me try to answer this. So basically, why I will not be going through this line, the reason is that is what makes your SVM more susceptible or more acceptable for this issue. When, if I draw a line even in the middle through these points, the reason is whenever some new points would come, that margin which is perpendicular to this x-axis, x1 axis, won't be at this maximum distance as this hard line was, as this maximum margin was. That is how they have determined. The line can be a straight line perpendicular to this, it can be a slanting line somewhat like this. However, we found that this was the line that got us with the maximum margin through the support vectors that lie at the corner of both the classes. So I'll show it to you that how support vectors and how all these things have been stated in a research paper as well, when we will try to open the repository and check into its details. So let us talk about the implementation. How do I do it with Python? How do I do it with Jupyter Notebook? And what is the popular library I can use? So you will be using the sklearn, scikit-learn, which is a very very popular library, and that is used to pick up your svm, or basically train your svm onto a particular data set. So we will pick up a data set as well from sklearn library itself, and then we will basically try to identify within this svm, or I would say within the support vector classification algorithm, that what are the different hyperparameters. So even when you are building your algorithm, couple of things are essential to understand. Couple of things, when I say couple of things, whether you see your kernel, it's linear. So I'll help you check out when you change these hyperparameters, how your model's accuracy increases. So I want to identify the tumor, I want to get as close as possible, I want a highest amount of accuracy with my model. So that is what we want when we are saying I'm using a machine learning model, trying to use some data that has been provided to me, and get into a training set where once I'm doing the prediction, I'm good to go with the result that is not stating a person without cancer as cancerous, right? So that is what we do have. I'll also talk about the false negatives when we'll discuss the code. So how do you develop quickly? So to quickly develop, you do have open source libraries, and that's how Python has become so popular. It's available to everyone and anyone. We always talk about it, and that's how your developer community is increasing and getting better day by day. That's how you are able to innovate and redistribute that same thing to other developers, and build up a global community of developers who do support each other through different repositories. So, but what do you check even when you are doing and going through this quick deployment using some existing code? It is important to check couple of key things. One is support, security, quality, and the license agreement. So if you don't concentrate on these four key considerations, then it may become a bit difficult for you to, you know, use someone's code, and maybe you may not redistribute it if it's required, depending on the license, whether it's permissive, it's copyright. So we are talking about open source, so mostly it will be weak copy left, strong copy left, those sorts of licensing you can get into. So where do you find all these licenses? Yes, we will talk about how Candy helps you understand these key considerations as a developer when you are trying to use some open source library to help you develop a quick project or a quick application to solve a real world problem. So let us go and try to do the prediction using our candy kit that we have curated for you. So we'll just go back, and I'll quickly, whoever has joined us a bit late, I will quickly share this link again. Okay, thank you so much. I am just seeing a lot of people from different places, and I just hope getting not installed on my laptop. Okay, Asad, can you help me with the issue that you are facing? I just stop sharing. I just want to understand what issue you are facing while you are doing the installation. Not installed on my laptop. Please go through this link. Click on the one click install. And Asad, if you can revert back, maybe we'll take up your doubt later in the session if you are not available as of now. However, what others have to do, you just have to go on to the Candy page. Here you click on this one click install, download this zip as a zip file. I've already told about this in the starting of the session. And once you once you come here, you just have to click on the kit installer. I mean, after unzipping, you just have to unzip this kit installer. You will get a folder. In the folder, you will find a batch file. Double click the batch file, and your installation would start for you. it would look something like this. And then it will ask, would you like to run this kit once your installation is complete? So if in case someone is still doing it, please try to just minimize the screen and understand the code that I'll try to discuss with you. So it is asking, would you like to run the kit? Yes, I would like to run the kit. So what this would do, it would automatically open a Jupyter notebook for me, right? So that should get open for you. In case all this is, not happening, or some of you are facing some troubles, so there could be an issue with your Microsoft tools. Let me help you with that installation also. I'll just have to check back that exe sometimes. Yes, VS Build Tools is something that you would want to download. So it's only in some people's case where these Visual Studio tools are not available that the download takes, like some issues are there. But your batch file should run. This batch file still should run. The code may not open for you. So you would just have to go to your build tools, and in that Visual Studio, just go and say, I want to download this, right? And this will start your setup, etc. So once you are done downloading that, right, for those who have mentioned that they are not able to go ahead with the installation, you can also join us on Discord and get your issues resolved, right? So I quickly would want to discuss this Jupyter notebook with you, for all those who are waiting to get into the understanding how we are able to do this breast cancer prediction today. So quickly we'll start from sklearn. This is one of the most popular libraries that are available, and this is basically, it's a complete group, or I would say it's a framework where you have support for data sets, where you have support for different algorithms, where you have support for different learning techniques. Everything is available. If you will even Google sklearn, you will get that it in itself is a big, it has developed into a big ecosystem where you can work with many things on machine learning and experiment with the help of this library. Okay, so yes, step one, you need to get all your libraries imported, right? So we will first go for sklearn. We will import the data set for this sklearn, and then from the sklearn, after importing the data set, you would now want to get the particular train test split model. What we want to do, machine learning basically entitles to, first step is training the machine, and then testing this machine. What the training that you have provided, how well your machine is able to respond to it. So there are two phases, one is training, another is testing. So that is what we are trying to import a particular, I would say, library for doing the model training and model testing. So that is train test split. Then we also imported your SVM from sklearn, and also metrics. So metrics are all those mathematical, parameters which I will use. Say I will use accuracy. Say I will use a confusion metrics to state how well our model was trained and how well it could help us predict breast cancer. So step one, I would just clear all the output and individually try to run each and every library and each and every cell with you. So it's still running. We'll wait a bit. Right, it got run. Now we would go into the step two, which is loading your data set. So how do you load your data set? You get into this data sets library that you had imported here from sklearn. On from that, you will use the load breast cancer function, so that you can directly load the toy. It's a toy data set that you would just load into a variable called cancer. Let's run that. You can also use, you can use a CSV file. For that, you have to import pandas here, right? So that also you can do. We have tried to make it as easy as possible for you. Next step is exploring the data. So we need to now check your data. What is the data set that is available? And how does your data set looks like? So we will just run this. So when you run this, we have just printed the different features of your cancer data set. So what all features are there? So if you look for, if you are a doctor or if you are a a person from the stream, you will be able to understand that to figure out, like, there is mean radius, mean texture, mean parameter, concave points. What all are, I mean, all these are parameters to detect the breast cancer and all. So that all that is mentioned here, like the texture error, parameter error, compactness, etc. And also you have two important output variables, or I would say two important output features, which are malignant and benign. So even as developers who may not be very much into this stream, or who may want to sit with an expert into biofield, they can quickly, and if they don't have someone available, they can we can help take help from Google and quickly search what malignant means and what benign means, which I've already mentioned. Malignant is, yes, it's a cancerous tumor, and benign is, it's not a cancerous tumor, it's a normal tumor, and it won't outgrow, right? All that you can do as student developers at your own end. Next step is, once you are aware what your data set has, you have these many parameters, and these are the expected output variables, that output features that you want to work on, output columns that you want to work on. Now you can work on training and testing of your data set. So we will use this train test split algorithm. I hope you remember we had imported this algo for model training and testing. So what we'll do, we will use the train test split function here, and we will imply it on the cancer data, right? The data set was saved in cancer variable. So we will call the cancer.data, and we will try to work on all the input features. Then we will also apply it on your output features, which are your target features, right? If you see, cancer.target names gives me my expected resultant features. Cancer dot feature name simply gives me all the 13 features that were there in the dataset. So first I implied it on this cancer dot data, and then cancer dot target to get the values of my output. Then there is another parameter which is test size, and this test size basically determines, or this test size basically helps you uh, fix the size of your data set that you want to use for training, right? So if I am putting the test size as zero point 0.3, if I'm putting it as zero point 0.3, I basically mean that I want to keep 30% of my data set for testing, and 70% I want to keep it for training, right? And this random state basically juggles up when it is splitting your data set. When we are splitting the data set, right? We, if you want, we can also quickly check this repository. Let us go to this solution code also available. Why am I doing that? Once you go and, okay, check. Okay, so I just quickly want to give you an example of, this was the one click available. I just also want to give you an example that how popular this current data set is on which we are working. Just quickly want to go on to the search feature of the Candy platform and simply typing our algorithm's name, right? So when I type this algorithm's name, I'll just check. Since there is a lot of changes that are being updated very recently, you see that MNNIST digital classification is also a very popular digit classification problem that is based on support vectors, and that is being also talked a lot in the ML community, right? So this is listed here. Then emotion detection is listed here. So many things. Support vector machine in JavaScript is also popular. So you don't have to be just aware about Python. You can do it with Python. You can do it with JavaScript. You can do it with Java as well. Efficient training of support vector machines in Java. So JLib SVM is also available. Then malware classification has also been done using some approach of support vectors for malware classification. So just wanted to quickly, and then there is a similar repository, not just the one that I have told you. There is this breast cancer prediction using SVM, again a popular problem which is also listed here. See, so you can go and you can also identify so many things, right, from these many, and then also what you can do. Okay, 1 minute. Yes. Also, what you can do, see, they have also uploaded the CSV file that I was talking about. So these are the parameters, right? We are talking about radius mean, texture, parameter, area, right? These are the 13. I hope it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there is more. We can scroll, I guess. So this is a big data set, 570 or so are the listed. I'm just trying to show the data set that we are, like, yeah, 570. 570 are the records that are available, and 13 features or columns apart from the target. Sorry, apart from the target, we have 13 such features. So that is what I am just telling you, that you can experiment by going onto the Candy platform with other repositories also available. You may not want to just use the one that I have given you. You can experiment with others like these. Maybe there's something on stock market that I was talking to you about, stock market prediction using support vectors. So this should be on regression, right? We can see it's on linear regression. It simply gives you a code of linear regression. So you can also use this repository into your own Python Jupyter notebook. So sorry for the switch over that I had done. The reason was I wanted you to understand that it's not just this code that you have to work on with. You can pick any repository that is available to you, and you can also check the different features of the this toy data set, because many people have worked on it and the repositories are easily available open source online. So yes, we were talking about how you are splitting it. Your 30%, since it is reserved for testing, the 70% is for training. Sorry. And you get these four parameters out of your training test split, so function. And what we are doing now is we are generating our model now. We've already we are ready with our data. We have split it into parts. Next step is we are using the model building. So for model building, from the imported SVM, you can also check the available. So just use shift and tab, and you can get into these details. Okay, this is a pager which gives you where all it has found the details. Sorry, coming back here, just go and press shift and tab, and then since I have chosen SVC, which is support vector classification, okay, I may also check for other options that are available. Currently, since I have not run these cells, I'll just quickly run them also, so that my intelligence also starts working upon building the model. So yes, you can check for different options available: support vector classification, support vector regression, linear support vectors, or whatever. And even in kernel, you this is a hyperparameter. You may choose linear, you may choose poly, you may choose RBF. So that is something that you can go and look for as per your problem and your requirements. and then build this model into a variable called, say, classification model. So we are just naming it as CLF. And then you can, after you have generated the model, you just fit the model onto a training as well as a uh, fitting it on the training data set. So we are training the model using the training data set, we are fitting it, and once it has been fit here, let me run the code. The training takes a bit of time, so it is giving us an output that yes, it has been trained on with a kernel parameter of linear. Next step is the prediction step. So just let's run the test data set, the 30% that we had, saved for testing our trained model. So we have used CLF dot predict function and passed the test x underscore test part of the data set, and then that we have stored in y underscore pred. Further, what we are doing is we are evaluating this model. So once you have tested and trained, now I want to check what is the different metric. How do I say that my model worked fine? So I am working with accuracy, I am saying precision, I am also talking about recall, I am also talking about an interesting metric which is your confusion metric, right? So I'll run this and I see the advantage with SVM that you may want to ask me why I chose SVM. Not only because the research paper chose it, the research paper clearly stated that you can check with naive bias, you can check with linear simple classification, you can check with decision trees. It completely depends on you. You tune the parameters, you choose the algorithm, and see with which model, with which algorithm you're getting the maximum accuracy. So currently, you see we are getting an accuracy of 96%. Precision and recall are also a great value, which is again 0.96 and 0.98. Confusion matrix here basically gives you very less number of false positives or true negatives, right? So you need to understand what are these true positives and false negatives. True negative is when a certain condition was assumed to, say a person had cancer, but the model said that the person does not have cancer. False positive is that the person does not have cancer, but your model says that the person has cancer. So these sorts of values should be zero here. This and this should have been zero. So the chances of your model predicting some wrong values, say out of 100, 96% your model is accurate, but there are still 4% chances that it may do some wrong prediction. So this is the best that our model could predict, right? What all you can do, you can try changing, you can try experimenting with the test size. Say I try to keep only 20% for testing and 80% for training. Let us rerun these cells. I'll just rerun these cells and see the change in the accuracy. It's running. Yes, because it is building up the model, it takes a bit of time. Now let us rerun this. So you see, by reducing the test size data set, my accuracy got reduced. So that matters. Somewhere in the confusion matrix, the value has also been reduced from 6 to 5. So that is a very small change. You can maybe check it for 0.25. Also, you need to understand the importance of testing and training splitting data set. You can't just split it by any number. You can't just say you need to keep maximum part of your data set for training and a bit of part, like a little bit part for your testing, right? So all these things you need to understand. Also, since we already understand that the data set is linear in nature, you see that the accuracy is somewhere, again I am getting a greater value of a confusion matrix. Now also these values have reduced. So if I go with a 0.25 test size, it's also not good. Let us just quickly check it for 35% as well as an example to be able to analyze. or else we'll go back to the yes. So you see this. Even with the 35%, your confusion matrix values with the false positives and false negatives is higher. Accuracy is again close to 30%, which was 96 point something. Precision and recall have reduced. So the best test size for now, you can also check by changing the random state value, how randomly the splitting of your testing and data, testing and training data set happens. So yeah, I mean, you are free to experiment at your own end. You can also quickly call your naive bias and experiment with naive bias also. So you see, this is the best that we can get, where accuracy is high, precision recall is high, and also your confusion matrix with false positives and true negatives lie very at a lesser low value, right? So I think this is what we have. This is a very simpler form of code that I have provided for you guys. If you will look into the code that is available, you may feel that it is a bit overwhelming, and hence you need to choose wisely what file is more suitable for you. So I think this one is for stock forecast. You can experiment with that. We can quickly check back that what more you can do. You can check for naive bias. So we have Peter sentimental analysis that you can do with naive bias, SVM, and CNN and LSTM. So you will get all the repositories linked onto a single page with these key parameters, right? You need to check as a developer that the repository or the library that you are using in the repositories, what support they have, how secure they are, what sort of a license agreement that repository has, right? So all this is listed here. That makes it somewhere easier for you to start with your development on a particular application. So again, I have just gone into this code and we can see the different libraries it has stated. Everything is stated, right? So yeah, very well, you can experiment with Candy. You can see how good and benefited it is for you. You can ask any doubts that you have. I am just open for any queries that you may have quickly uh, for now. And yeah, please go ahead if you can. Okay, someone says that they are on the phone and laptop got broke, so they couldn't install. That won't be an issue, ma'am. May whenever it is, like whenever you have it, we can work with it. What data parameters are used for determination of benign or malignant nature of breast cancer that are fed into this AI model? So, Mohammed Saini, that's a good question. The thing is, uh, there are a couple of model parameters. I've talked to you about the features that are pretty much available. I have used a existing model which was already present in my SVM and directly implemented it by changing some few parameters. I have not even changed the kernel parameter. By default, it was set to linear. I have just directly used the linear parameter. So you can change it to poly, RBF. You can change a parameter called C, where the C value basically, based on the changes that you make, it tunes your parameter for better prediction. Then I will just quickly look for other questions. Okay, so for those who are not able to install, first of all, one thing is I have asked you to install. Let me share those Visual Studio Tools link for you. Maybe that is the reason that you're not able to install this kit. So I'm sharing the link. I'm not talking about the Code, VS Code. I'm talking about the Visual Studio. Basically, it's for C++ development and all. So that helps a lot of libraries to get directly installed. I'll just share it in the link. share it with the link, sorry. Once you install this and then do the installation, then your installation should not stop. And even after that, if there are issues, uh, okay, Afsa has a good question. Afsa says that, do you think that changing parameters and adding more will improve the results? So, Afsa, I have shown you a very small change that I made in just the test size, but it depends what you are looking for. Is accuracy the parameter you are looking for? Is true negatives and false positives also something that you are looking at? I would say we look at the overall matrix, how less false results we are able to achieve. If you say there is a research paper, I'll just share my screen again and do a quick search for you. I hope my entire screen is visible. In fact, why am I even putting it here? In the platform itself, the link that I had provided with the kit, the entire, like, if you scroll down, you see I've listed the library here. And we are going to send you an email where we are going to send up a follow up email at, to this one click, where you can go and find the data set. Maybe I'll show you that as well. Just give me 1 minute. Okay, it's taking a bit of time. Yeah. So it's a getting started with Git. Getting started with predictive analysis. I'm going to send it to you in the email. This is a cookbook. Hmm, taking a bit longer than I anticipated because of some changes in the click results of the library. It's taking a bit of time. What I'm trying to say is, when you do a search for breast cancer prediction, you will find you will find it on elsewhere itself, where it will talk about that how this support vector, they have implemented random forest, they've implemented logistic regression, they have implemented decision tree and k nearest neighbor as well. On this same, this is the Wisconsin diagnostic data set that was provided, and based on that, it is observed that support vector machines outperformed all classifiers and achieved the highest accuracy. So still I have not been able to go up till 97.2%. So you can go ahead and like follow this and try to reach that exact accuracy. See, check this out and use this research paper if you really want to explore as much in detail as you want, so that you are able to yeah, thanks, Asfa. You're able to follow as much as possible in detail about, say, you can experiment with random forest logistic regression or something like that. Sandhya, I think we can quickly share the link for the Discord channel with our participants so that they can look forward for more sessions with us, where we'll recently are planning on a very basic session this Friday based on a requirement that came by many of our student developers who are interested in just the basics of Python as well. They are a couple of student developers with us, and we would be we'll be more than happy if that helps. So you guys can also join. The details for that session and all could be provided to you on this Discord channel. The link is provided in the chat. Please use that link to join the Discord channel. Also, uh, in case you have any sorts of doubts regarding technically, you can ask for help in most of your programming technologies. I am more good with your ML, but we have thousands of developers there who can help you alongside a team of our own open weaver who tries to solve issues for you. And yes, Amar Kumar, thanks. I see that you have already joined, and you mentioned that those who are new for this session they can join. And yeah, we will be coming up with a new session. Also, we'll share a certification link today, and those who are like willing to get a professional certificate for this session, they can use it to share on LinkedIn and talk about how open source libraries are benefited. Just like us at OpenWeaver believe that more the open source nature, the better it is. Okay, great suggestion by Jane Toms. We do organize hackathons, and I think one was organized in January. So, based on the student requirements, we do organize it. We are taking up some time to understand the key projects that students are looking forward to, and accordingly, we will organize more and more. And we look forward to you participating as well. Thank you so much for your suggestion. Okay, I think I would close the session here. And even if you still are not able to resolve the problem, you can discuss with me on Discord. I'll be available there. Thank you, everyone.
Thank you, Pooja. So this will be our end of the session. So thank you all so much for participating throughout the session. So if you're having any queries, feel free to drop a message in our Discord channel. Our instructors are always available there. So once again, thank you. Thank you all. Have a great day. Thank you.